Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Lumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Illumin's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Illumin's website at www.illumin.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
Thank you again for joining another edition of the AI Innovation Space. I'm here with my co-host, Todd. Todd, how are you doing today?
Very well. Looking forward to our conversation today.
Yeah, I am too. We have Ali here with us. Ali is a machine learning data scientist or machine learning / data scientist at Ericsson. Ali also is doing his master's or probably just completed his master's, done a lot of mentorship in the machine learning space. I think one of the reasons why we're really interested in talking to Ali today also, Todd and I had this conversation, is because we would love to also learn about basically what it looks like doing machine learning and artificial intelligence in the European world. And so we're really excited to have you, Ali, on. Welcome, Ali.
Yeah, thank you very much, Ian and Todd, for having me. I'm super excited to give my insights and from my previous experience in machine learning. Just a small comment: it's like machine learning engineer / data scientist, because like machine learning by itself.
I know. So we're gonna get started here. I think we typically like to start off with you doing a bit of introduction about yourself, and helping our audience or understand some of the things that you've done before in the past, how you got into the field.
Yeah, so I basically started since I started working in this field in machine learning, which is the field I like most and I love talking about, is since around 3 to 4 years ago. During my bachelor's, my favorite subject was mathematics, and I also did a degree. I did like 2 degrees in mathematics and also computer engineering, but I only found myself comfortable, or my most place where I related to was in the course of machine learning that I took as an introduction during my bachelor's, because it basically applied all of the mathematics that I learned throughout my years inside computer science. For me, artificial intelligence is another word for mathematics and computer science, or in algorithms. So once we apply these algorithms or mathematical formulas inside the algorithms, this is where they start these buzzwords of data science or machine learning or artificial intelligence. And I think this field has proved throughout the past years, especially after the hardware accelerators and the GPUs, and the availability of large data sets, all of the industries around the world have been started investing a lot. Now it's the future. It will be if not already, but it will be next year or the year after. It will be like electricity. We cannot have any product without any AI accelerated feature of any product. I've been working in this field since I discovered my passion for it 4 years ago. I worked in many projects related to computer vision. Computer vision was mostly the thing, but I worked in many projects related to natural language processing, particularly chatbots and embeddings, text embeddings, and the such. As well, I went for the emerging field, which is explainability in AI, like how to explain why the network is performing this way, and also a lot of recommender or recommendation systems that we developed for some startups or some companies in Sweden.
That's really, really awesome. I know that in Stockholm, there's been a whole lot of work around smart cities, and we actually had a conversation with one of our guests on smart cities and smart technologies and things like that. And so it's really exciting to see that you're also into the computer vision space. Todd, you had some questions?
So, Ali, you got a master's degree, I believe, in machine learning, and then you've also done some further coursework with like edX, Coursera. So how does the coursework that you did kind of help fill in some gaps, you would say, from your master's degree?
Yeah, I think like I did a lot of courses from organizations such as edX and Coursera. And I think these online courses are very, very helpful, especially during COVID when people that were not able to go to university or had some struggles with learning alone or from, yeah, like they couldn't follow lectures because of this virus and everything. I think these online resources helped a lot. And even after COVID, like at the moment, I'm still taking courses on Coursera that help further in the research. So right now, if I want to share some personal details, I'm taking some courses on machine learning operations on Coursera, which has been one of the like companies are driving towards having this skill to while joining companies. It's like for me, this is something definite for any person today who wants to go to industry and machine learning. He has to have this skill because it's attaching link between the research and the product, like how to productify your models after. Like you can do research 24/7 without having any money from it, then you cannot make a living from it. This is how industries are pushing towards how they're pushing towards implementing this skill or having this skill. So Coursera is one resource that you can learn it from.
I see. Great. So could you dive into some details? I know you did a master's thesis when you were working on your master's degree. Can you tell us more about what you worked on with your master's thesis and how that had a machine learning component?
Yeah, absolutely. So, and actually, I just had a presentation recently on that because we're continuing further this project. So my thesis was basically I did it at Ericsson, which is a the biggest Swedish telecommunications company, and we basically had the following hypothesis that today companies, or at least the telecom area, we are missing a part of our modeling of the network. And to remain leaders in this domain, we have to invest all what we can to enhance our modeling of algorithms. So one data that we were missing in the company is satellite imagery. So what we did was we developed a method or a methodology that we right now we have patented, like we have sent multiple patents on this, like how to enhance this prediction or the modeling of the network with information from satellite images. So what we did was basically, so telecommunications is basically comprised of KPIs, which are key performance indicators. So we selected a few KPIs and we developed a method to optimize these KPIs to have a quantitative measure. So what we did is basically we first it was like a two-phase project. So the first phase was a computer vision phase. We went and explored satellite images. We so today there are more than 4,000 satellites revolving around the Earth, and they are like imaging satellites. So it's not like normal satellites for streaming or other things. They are specialized for this type of information. And they have like different lenses capturing images across the Earth 24/7. So we scrape these satellites, one of these satellites, in particular it's called the Sentinel Hub, Sentinel satellite, which has a Python package or Python interface called Sentinel Hub. We used it to scrape our images and collect our data set. And using these satellite images, we were able to train a deep learning model, which is basically it was a CNN-based model to infer or to embed these regions. So for example, if we have urban areas, we embed them so that they have the vectors of these regions will have similar numbers, and like beaches or lakes, the water will have like similar vector embeddings, and so on and so forth, like industrial and business and so on. So once we have this extra information, like the top level information, we can go ahead and try to cluster or group these similar regions so that we can predict the future, like to model on an optimized way. So use case specific. So for example, inside enclosed areas, like inside the buildings or inside like under the subway that goes underground, if we can capture this information, we know that, for example, these regions have similar characteristics and that the signal will have hard time propagating in closed environments. So we optimize use on a use case specific manner, in a use case specific manner. And this was the first part, which we had to identify these regions into different types using deep learning models. And the second phase of the project was to actually predict the KPIs. We compared between multiple models. We compared once without actually any extra data, like we just evaluated the classical approaches, and then one with this imagery dataset, and a third one was basically adding more datasets to see if more datasets will help or not. The logic says yes, but usually the modeling is not corresponding to the logic. So we basically added a third dataset, which is weather. So is it rainy? Is it cloudy? Is it sunny? And so on. We noticed that adding this third dataset doesn't really help a lot. We have some like ideas why that was not the case. And I can say something very briefly is that usually the seasons change, but the places remain the same. So that was our like intuition why the weather did not change. So if we stuck to like one season, like the winter or summer alone, maybe that could have gotten better results. But our results showed that using the images on top of telecommunications data basically had like much better performance than previous approaches. And right now we're trying to productify our idea, our models. And that's one of the things that I'm doing right now. Like through this machine learning operations, I'm still in this, we are still in this process of sending this model to production while ours with all, of course, our stakeholders approval. So, and I have even my like report. If someone is interested, I can link it somewhere. But yeah, this is in a nutshell my thesis project. I hope it was not too complicated, simplified as possible.
No, that was good. Thanks for sharing that. I think that it's a very interesting approach that you guys are using. So I would assume that this was Ericsson in collaboration with Ericsson owns those satellites, correct? Or
Yeah. Yes.
oh, okay. Okay. And so basically those satellites already capture images, correct?
Yes.
Or did you have to install a sensor to capture those images?
No, I mean, so satellites are just available in space.
You already, yep.
There are two types of satellites. There are commercial satellites, and there are like satellites that you need to pay for to get more data. So for our proof of concept, we went for commercial data satellites that are revolving around Earth, and you know the lenses that are attached to these satellites are like they vary according to the frequency that they send light, so that they can capture the image. So they come with many different bands or bandwidths, and so we have like the RGB, red, green, blue. You have also color infrared, 1, 2, 3. You have shortwave infrared, which is 1, 2, 3, 4, and some other, yeah, many more bands. And I conducted in my phase 1 project experiments with the multiple combinations of these bands. And according to my results, the best performance of my model in extracting these embeddings was when I used actually color infrared bands. So color infrared is kind of different from RGB that we, like the human eye, can see. So if you go further into like different frequencies of things that happen around, the models showed that it's even better. Like the models or the mathematics can see better than what we humans can see from our naked eye.
Oh, wow. What was the difference between the infrared and the previous?
So the satellites that revolve around the Earth, they revolve in space, and it's a bit dark around. They have to like have like this flashing.
I see.
And this flashing actually goes like it sends photons or like light waves. And these light waves they go on different frequencies. And every different like our eye to be able to see around, we have either sun from light or even we have like small, very small light emitted from our eye as well.
Yep.
But we can see only RGB, like three different frequencies. I don't remember the numbers. I don't want to say numbers that are wrong.
Wrong.
Uh,
Yep.
but they are something in the like hertz, like the unit. So color infrared is just a different hertz number than the
I see.
RGB unit.
I see. This is Todd's space, so Todd could probably relate with what you're saying more.
For sure.
Yeah.
I think
We can ask-
space and AI is very interesting field in my opinion. It
yeah.
has very promising fields or for the future.
So, Ali, thanks for sharing more about your master's thesis. Can you explain some of the societal impact on the potential that you developed? Like, what does it have the impact to do that might have been differently from what Ericsson was able to do before your work?
That's a very nice question because today, especially after, I don't want to say after COVID because COVID is not 100% out yet. But it's like one of the major impacts that or problems that we on Earth are facing, like us all humans and even other creatures, is like we are having this impact of global warming. So like all this CO2 emissions and all these forest fires and all the natural disasters that are happening, they happen for reasons, and it's like the industry has a very large impact on this what's happening because we emit a lot of like CO2 from our experiments and burning of fossil fuels and so on. So to link it to my thesis, to my project, we had actually one conversation with the environmental engineer at Ericsson at some point, and we have his paragraph linked in my report as well, that this approach that we are doing, it has an impact on the heat consumption of the radio, because basically the radio consumes like the most one of the radio unit. When I say radio, is just the part of the network that sends signals or to the antennas or it's like part of the antenna. It's like sends signals to other radios on other antennas. So this radio unit, if we can optimize this prediction of the KPIs, we can reduce the heat consumption of these radios by a factor. This factor needs to be studied according to a use case. So from my point of view, if I can contribute by 1%, if that's possible, to the world, like global warming or societal impact, I would be so happy. I would have fulfilled my mission. I think this is one aspect of the impact of my project. If that's what you meant, Todd.
Yes, thank you. That's very interesting that it can help in that regard.
Awesome. So I wanted you to touch a little bit on your work in the recommendation space, recommender systems, just generally speaking, what have you done in that, space? I'd like you to share a little bit about that.
Absolutely. And actually, recommender systems is my second favorite field of machine learning next to computer vision. And I think for me, like when I combine these two fields together, it will be like my favorite project if I want to do something later. So I worked on multiple recommendation models. The most recent ones, so I did 3 recommender systems, and every time I build upon my previous experience through the projects. The first one was on Goodreads data website. We recommend books for users throughout Goodreads. And of course, the 3 projects are available open source on my GitHub account. So this was the first one. The second one was music recommendation for Spotify songs. And the third one was recommendation of movies based on Netflix, series and movies. And it's user-based. And I can sum up all my experience and not talk in deep on each one of them. So in recommendation systems, there are two types or two main like deviations of recommendation. There is user specific. So you recommend based on the user's history of movies or whatever music or books. And also you can recommend based on the communities or collaborative filtering. So you see what the community is recommending, and then you can recommend based on that. So, for example, if I'm in Sweden today, and I go to the US and I create a new account, probably the recommendations will be all about what the people around me are watching and movies. And if someone in the US comes to Sweden, he will probably see like all Swedish TV shows and so on and so forth. So, and recently there has been like efforts to combine these two fields together. So like collaborate or add both collaborative filtering and user-based recommendation into one larger model. And basically, that's what I did in the last project. The first project that I did on Goodreads was basically user-based. So it used the previous user's history. The second project used the collaborative filtering. So the project on Spotify Music used like what other people are doing and then predict. On the third project, I combined the most of what I learned to that point, and then I developed a two-level recommender system that develops or that recommends based on both users' history and the collaborative, like the community's preferences. So, first, for that was for movies. So what I did, if I want to go deep into the modeling, you take a movie. Every movie has a script, and every movie also has an author, an abstract, and a title, and a date, and many other input parameters. So in some way, a person or a data scientist can basically join this to represent embedding for this movie. So, and you can do the same for music. Music, you can take signals and embed them, and then develop a model based on these signals. So for the movies, I took these scripts and the abstract and so on, and I developed a method to generate an embedding for this for each movie. And so the next step, once we have these embeddings, we have to generate. I started by generating the user-specific recommendation, because logically, if someone in the US comes to Sweden and logs in, he wants basically to see everything that that comes from his previous history. He doesn't want something that's completely irrelevant. But as well, he wants to see other people, what they are seeing in this location. And this is part of like socializing, like social networks. So the first step is we take like this previous or the history, like the history of the user. We generate every embedding for every movie in this data set. Of course, it's Netflix. The next step, we try to predict something that relates to the previous history of this user. So let's say I predict 5 to 10 different movies to be social. Now to go to the next step, to socialize with other people, we do the same procedure, but for all the other communities inside this location or around him by a certain region. So we generate embeddings. We generate embeddings for the user's history, and then we compare the two together. So this part is called collaborative filtering. So once we and this comparison can be very easily done. We can either we can go as simple as a cosine similarity, basically, just a matrix of similarity between a set of vectors. And that is one way basically to generate collaborative filtering. And by this method, it exploited both collaborative filtering and user-based prediction. And if I'm not mistaken, this project used a network called neural collaborative filtering, which is a bit more complex than cosine similarity. Well, not a bit, but much, I guess, a bit more like it's a neural network approach. But cosine similarity also can work. But the idea is like similar, it's the same. And also this project is available, the three projects are available open source if someone is interested in like reading more or like learning about how recommender systems can work.
It's awesome. Todd, you were going to ask a question, sir.
Well, yeah, that's thank you for sharing. So I'm just kind of curious, when you worked on these recommender systems, was it just kind of like a personal interest? I don't think you were working on this for any company or anything. So can you explain some of the motivation behind that?
Yeah, so these projects were part of my master's degree, and some of them we were able to present for some startups around Stockholm. So they were mainly part of this main reason of us working is to fulfill our requirements of the master's degree.
Sure. Okay, thanks.
Awesome. Thanks so much, Ali, for sharing. I wanted you to go into, we started this conversation earlier, but I just wanted you to share it with our audience. What are some of the things or some of the waves in the AI ML space in Europe in general, right? What are some of the things that are happening, some of these significant, events, taking place? Where do you see AI ML fitting into the landscape of the European continent?
Yeah, that's also a very good question. It's kind of strategic. I can maybe elaborate from my experience because it's like an individual experience. So I think in Europe there is a lot of initiatives to influence or enhance the AI architectures and infrastructures in universities and in industry. Personally, I was part of this process in Sweden and my university, KTH Royal Institute of Technology in Stockholm. I participated in a program that called the PICA, Professional Compliance Education. The main idea behind this initiative or project was to help industry engineers who are not aware or who have not had the chance to learn AI throughout their careers and teach it to them in a simplified way that doesn't include any buzzwords or like something very hard or impossible to do or doesn't require a lot of like impossible mathematics to implement. So that is one initiative that I was part of, and it received a very good positive reviews from all like our stakeholders and the companies that we participated in inside Sweden. And if I'm not mistaken, there were invited people who were outside of Sweden. Maybe they were in different countries, but that's something I was personally involved in. And another thing I know is that there is a lot of collaborations that are happening across Europe that are trying to enhance AI to the maximum level. One of them was, and I joined it last week or 2 weeks ago, I don't remember anymore. It was called European AI Summit, and that happened in Berlin, and it was very interesting talk. It included speakers from all around Europe and the US as well. And the main idea behind it is to help or keep Europe up to date with the AI research, all help, and also enhancing all the young talents across Europe. So at the end of the presentation, three startup teams won a total of maybe 50,000 euros to continue their work. And these startups they had a lot to do with like mostly computer vision and data science. Like one of the projects was how to help the medical imagery with AI enhanced tools and so on and so forth. So briefly, I think we are still trying our best to push forward. I think Europe is very great place, and right now we are trying to push forward to the AI. It's not as fast growing as the US. The US have much faster pace in terms of AI publications and applications of AI and the investment. It's much larger than Europe at the moment, and that can be actually seen in the yearly published Stanford paper on how AI is, or which regions or region-specific influence on AI. It shows that the US is going like much faster than Europe. But if we think about it, I mean, the US is much larger, and their like the impact factor is also larger than Europe. So I think Europe is trying its best. I think it's only going forward. True that, like you heard about, for example, how the big companies are unfortunately firing employees across the FANG, the five big tech companies. But if you look at the statistics, they have not, like, they are not firing from the R&D or AI sectors. They are still investing in this, and they're still hiring in these sectors, and that's even still happening in Europe. So I think AI in general in Europe or the US still is still and will become like the future electricity.
Great. Thank you for sharing, Ali. I'm curious, when you were talking about this European AI Summit, you mentioned they had some competitions. Have you ever participated in one of those? Do you have any interest in doing something like that?
Yes, I participated in so my during my bachelor's I participated in the engineering bachelor's competition startups in Lebanon because that's where I come from. Back then, we won the first place award for all across all the engineering startup teams. We developed, in a nutshell, we also targeted global warming. We noticed that across the Mediterranean Sea, where there's a lot of trees and a lot of like nature is around, there has been like some migration of very weird parasites called processionary moths or something. I don't remember exact name. PPM in short. They were invading all these trees across the Mediterranean, and they were surviving by eating the roots of these trees. So the industry or the trees, if we don't want to talk about industry, the trees were dying and nature was being affected very badly, terribly. Like in Lebanon, the pine trees decreased by 15% in 1 year back then in 2019. I'm not sure about the status at the moment, but back then we developed this product, which is a drone. We developed a model for this drone to navigate across trees and precisely spraying the nests of these moths. So we were targeting like something called precision agriculture. And precision agriculture is a very specific term inside the agriculture and AI industry, in which we don't want to waste a lot of energy of the drone or power and battery time. And also we don't want to waste the pesticide that we are spraying. So we want to precisely spray this nest once we detect it. So we uploaded a computer vision detection model on top of this drone. And this drone, we don't even have to drive it. It just goes autonomously across all the forest and detects particular leaves and where the nest is with a very high accuracy. And if we want to share the details for someone who's listening, it's probably YOLO. It's YOLO V3, which was the best model back then. You only look once. It's called V3
Yeah.
version.
So let me ask you one question about that. So what was the model of the drone you guys used? And two, do you guys have that code on GitHub?
That's a good point. Actually, this is the only project that I don't have this code on GitHub, unfortunately. But
I was about to go get it.
yeah, but the thing, like, this is like actually open source. So all the like coding for the drone, from the robotics part until the computer vision detection part, this is all open source. So we used a drone called Bebop 2, or yeah.
Can you spell that for me?
Yeah, it's BEBOP.
Thank you.
So yeah, there is like an open source implementation from a researcher, and I don't remember which university, that makes burdens easier by removing all the like hardware accelerators, and it's just like a Python implementation of this drone controlling system. And on top of this, we developed like an autonomous driving mechanism that uses YOLO, and also lidars actually. The lidars were used to detect when a branch is coming across or close to a tree. So once we receive a positive signal, we just freeze the drone, and then we see like we activate the vision algorithm and we ask like the model, is there a nest detected here? Yes, spray. No, don't spray. So that's like very easily said, but we had to do a
That was
lot of
pretty cool.
optimization.
That
Yeah,
was pretty cool.
and that was part of this competitions that I joined. It was one of the competitions, and yeah, it was mainly for precision agriculture and global warming that won the first award in that competition.
I see. Excellent. So that was a great project that you worked on. One other area that you've worked on that I don't think we've talked about yet. I know you can't necessarily go into all the details, but I'm kind of curious about your work on chatbots. Can you kind of expand on some of the chatbot work you've done?
Yeah. So chatbots, so there is one of these large companies called the Hugging Face Transformers, Hugging Face, and that's based in well, it's a remote company, but mainly it's based in Paris in France. And I did multiple chatbots, and I also learned from my experience. One of the things about chatbots is that they require a lot of data to train on, and that is why transformers came into play. And transformers, they have this attention mechanism that gives attention to particular parts of the sentence so that the model can learn in the future, not to forget. Even if this word appears once, but it's very important, then it can learn from the future how to use it. So for chatbots, I did one personal chatbot and one chatbot for the company that I work in that actually is still being developed. And we used a lot of bird related. So Hugging Face has implemented almost, if not all, of the transformer based models that are published on ArcSci for other conferences. And one of the major models that are implemented or published are called BERT or BERT-based models. So BERT is just like a model of attention-based model for language modeling, and there are many deviations. Like there is SBERT, which is called sentence BERT. There is a QA BERT. There are so many different approaches. And for my use cases, I developed using this Hugging Face implementation of the SBERT sentence BERT model. I can't delve into a lot of detail on this because there's like an NDA from the company about it. But this is briefly what we did, and we also developed an open source like a dataset for telecommunications, where we tried to infer the information given from general public datasets on specific telecom datasets. So we developed so there's something in machine learning called the knowledge distillation or transfer learning, where we transfer the knowledge given from a domain into another domain. For example, transferring the knowledge given for a cat to a dog. So when the model sees a dog, it's not something completely different from a cat. And for chatbots, you can do the same. You can train a conversation that we're now talking, like us three. We are now talking about AI, but we're talking in English. So if we transfer this knowledge into another domain, let's say we fix the language to English, and then we change the subject into biology, for example, or chemistry. Then this model will transfer the model weights from this AI conversation to the biology or chemistry conversation. And that's also what we did for the chatbot of telecommunications, because we had some pre-trained models on very large datasets, and we learned it to our particular use case in telecommunications. And it's an internal project that is being used and still being enhanced. But this is briefly about the chatbots that I'm working on. I have worked.
Excellent. Todd, you were going to say something. Sorry. I didn't mean that.
Yeah, thanks for sharing. So What do you think the chatbot could potentially do in the future for companies without going into too much details? Like, what do you think the main benefit is of the chatbot?
Yeah, I think chatbots are very important for many reasons. I think it reduces a lot of workload that doesn't have to be there in the first place. And if you come to Sweden, or if you have visited Sweden before, you would know that actually most of the companies today, if you call, they are mostly chatbots that they reply to you today. I'm not sure how it's in the US at the moment, but here they reduced the efforts a lot because so one of the applications of chatbots is like direction of the call. So instead of having a customer service with everyone replying to everyone, you can specify this location or this office is for these people, this office is for these people. And then on top of them, you have a model that directs this call to this particular individual. So this is one application. Another application could be like replying to business related or work related emails, or which is already, I think, there. So if you're busy and you want to automate the messages based on your own influence or your own idea, sorry, then you can automate it in a particular way. There is a lot of research, like in general artificial intelligence, which is another concept. There is this idea of learning human personality from learning the person's own like chat. So if you try to chat with yourself and then try to learn what do I really think, what do I really feel, and so on. So there are these types of applications as well.
I see. All right, thanks for sharing. So one thing I'm kind of wondering, you've touched on various projects and work that you've done in the data science, AI, machine learning space. Are there any challenges that you've kind of faced in general with developing some of these machine learning products and models, and any concepts that you think would be potentially beneficial for both yourself and others in the future?
Hell yeah. I faced a lot of problems. I think one of the so two of the main problems that I faced. First one is computation power. Second one is data availability. When I work in open source, these things are not a problem. When I go to Kaggle competitions or any sort of open source or online competitions, this is not a problem at all because data is open source and you can train and play with the data and like do a lot with this data. But when it comes to confidentiality and company related work, this is very kind of a bit hard and it's company related. It's company like use case specific. So like telecom data, for example, is kind of very, very confidential. It cannot be applied to any server. It cannot be applied to any external organization. It has to be like there are people paying for this data, like companies paying for this data to acquire it so that they can give customers particular prices and perfect hardware according to their data. So many times we have ideas, but we cannot implement them because of the absence of data. And many times we have data, but we don't have resources. Like we have sometimes there are times where you don't have access to like the best computing powers like available because maybe other people are using it, or maybe it's very just a deficiency that you can't pay or afford to have stronger resources for computations. And this is not only company related. Even if you're working on personal projects, if you want to like query resources or GPUs from like Amazon Web Services or Google Cloud or other resources, you have to pay for these resources. Otherwise, you have to buy your own machines or like the latest GPUs. And yeah, like I mean, recently NVIDIA also published the latest GPU 4090 Ti, which is the best computing resource up to the date that now we're talking about GPUs. So I think for me, the most problematic times where I didn't have either data or resources.
I see. I definitely know I relate, and our audience relates to what you said there about lack of data being an issue and lack of computational power. So kind of related to that, if someone today wanted to get involved with cellular network traffic prediction, like you've done with Ericsson in your master's thesis, like do they have a chance to do anything with that, with open source data, or do they really need to pay for some sort of a data set to use commercially?
That's a great question, because satellite imagery that I used for my thesis was mostly open, well, not mostly, but it was all open source data. And this comes with the cost, right? So this open source data is not usually the best quality of data. So the lenses of the satellites that we that generates pictures, it has a resolution of 1 pixel of this image is approximately 10 meters or 5 meters resolution. So like all, yeah, like it's not very accurate. It's like 1 pixel can cover, for example, 2 fridges. I'm just trying to show how what it looks like. However, 1 pixel is very small, right? So imagine 1 pixel is showing like two beds, for example, and then better imagery. I can't remember the names of the satellites, the imagery satellites. Better satellites have much higher or better resolutions. As I mentioned before, the project was was a proof of concept, the point, and that's why we used the open source free datasets. Other datasets, such as coming from better satellites, they have up to the millimeter or centimeter resolution. Like 1 pixel can have 50 centimeters much of data. So it definitely comes with a cost. Free is good for the pocket, but it's not the best for performance. So I think investment in data is something that needs to be addressed. And this is one of the main points that was actually addressed in the European AI Summit, that they wanted to invest in acquiring more data, that the US has much more access to data than in Europe. And we have like in Europe, they want to start working on this to build like massive data sets. And when I say massive, it's not like in a village or like in a city-wide, it's like on a country or a continent-wise data sets.
I see. Okay. That makes sense that you want better performance. You got to pay for the data right now. You know, one other thing I know Yano and I are interested in is if you've worked in different applications and areas in the machine learning and AI space, are there any other applications that you haven't yet worked on that you see machine learning being helpful for that maybe one day you will work on?
Yes, absolutely. And I really love this question, because it's very like to the point that I really want to work on something, but I cannot, because like people don't see sometimes the power of this thing. I think one thing that I really want to work on, and I think right now I cannot do that unless I go back to academia and I go back to PhD, is something that's very specific in deep learning. It's called geometric deep learning, something I really want to go back to. And it's completely different from the previous approaches, and I see a very large potential for this field. It's not very new, but it is new. Like it is not more than maybe 5 years old, maybe, or 10 years old maximum, I think. It's basically how to transfer our data or all our models and data to a different space that what we see in our with our eyes. So it's like going back in history shortly. I mean, this is a discussion by itself. I won't make it very long. But going back in history, there was like this debate between mathematicians on the nature of geometry. So Euclid, all the high school geometry or even basic courses of math and university that we take, they're all of them are based on five postulates really that were laid down by Euclid in his book Euclidean's Elements in the 16th century. And then 2 decades or in the around maybe 18th century or something, there was debate between mathematicians, and then they debated the fourth or fifth axiom, I think, or postulate. I don't want to say the details of this postulate, so I don't like say it wrongly. But it was something on the parallelism, like how do you define parallel lines? And things evolved, and then they came up with something called like hyperbolic geometry, spherical geometry, ellipsoidal, and so on and so forth. So each one depends on its own metric. So today I don't see this implemented really in any like modern deep learning approaches, even though there are papers. Like there is a paper in 2012, if I'm not mistaken. It's on hyperbolic gradient descent, but it didn't have a lot of like all the models that we see today, like the transformer-based models or the other like deep learning approaches, they don't really have this implementation into their frameworks. So this is really a field that I really would like to delve inside. And one of this field, one of the like examples of geometric or non-Euclidean deep learning is like a graph neural networks. So graph neural networks is one example of non-Euclidean deep learning. And another field is called manifold learning. So manifold learning is trying to learn on a manifold. Manifold is just like the extension of a surface. Surface is like 3D shape. And manifold is like the generalization of a surface. It doesn't have to be something that sticks to our own eyes. Like I don't have to see that there is a surface in front of my eye to say that there is a surface or not. So if I map my eye coordinates to a different space, this is like kind of manifold. It's just a generalization, and surface is one example of a manifold. So manifold learning is another field of machine learning that has been developed recently a lot, and graph neural networks as well. But for me, I think if I wanted to go for a project that is not yet implemented today, it will be definitely hyperbolic deep learning or some sort of geometric deep learning that is theoretical. Even though they're like the industry does not see the power of this, you can take my word, but I think in a few years this will have like this will be something. This will be the next AI program. Like for example, in 2020, transformers were the breakthrough in modern deep learning, and now almost all models are using transformer-based approaches. I think for me, once we have this future like breakthrough in geometric deep learning, this will lead the field in the future. So this is one of the things that I really would love and admire working on it.
Great, thanks for sharing. So we'll check back in 5 years, I guess, and see how your prediction turns out. But that's very interesting to share here. That
I will be waiting for the email.
Yeah. So there's one more thing I wanted to touch on before we wrap up here, and it's on the subject of transfer learning. You had brought it up earlier. I don't think a lot of people are that familiar with transfer learning as they are with, all the other concepts in machine learning. Can you explain to our audience what transfer learning is real quickly?
Yeah, for sure. Transfer learning, I can give like a toy example. So imagine that you are a young child and you're learning throughout your days. So you have never seen, let's say you have never seen a rabbit before, but you have seen like a dog, or you have seen a cat, or you have seen like, I don't know, like some other pet or animal in your life. Now, this child, when he sees the rabbit for the first time, he's like, he identifies it. It is something, but he doesn't know its name, right? But he knows that it is something living. It's like an animal. It's like belongs to this species. It's not a human. So so this child, what he did in his brain, so his brain is basically a neural network, a human neural network. What he did, he had just associated the weights of his network. He associated this creature with animals. It's it's definitely not a human because it does not look like a human. So the weights of his brain, they are trained to see to identify humans, for example. And once he sees this rabbit, the unseen new object, he will like his network will identify that these weights, when they fire, they are different than the weights of the human. So that's how he learns that this is something new. Now, if you want to learn for artificial neural networks, transfer learning is the same thing. You have a trained network. Let's say you have a trained network on like the sciences excluding biology. Let's say it's trained on geology, on chemistry, on physics, on something else, but it's not, let's say, trained on biology. So there are multiple approaches for transfer learning, but the main idea is to take this network that is trained on all these different sciences and then get this new science and start training starting from these weights. So not starting from zero, not starting from like a random weights or random initialization, because usually you randomize the weights in the beginning of the training. So you don't start from there, you start from previously trained network and then you train on your new objective, because the weights will be similar. Learning like the minimal loss function will be closer if you start from there rather than going all the way from zero to the zeros of the training loss.
That makes sense. Thank you so much for sharing that.
Absolutely.
So we really appreciate you coming on, Ali. It's been a great conversation and hearing more about your experience and insights.
Yeah.
Yeah, I would like to take a moment to thank you, Todd and Ayano, for reaching out. I hope that my conversation helped someone or any person interested in AI or like who wonders about the future or just any sort of input I could have added to his knowledge. I would be like so happy about that. So thank you a lot for having me.
Thank
Sure,
you.
you're welcome.
We're
Thanks.
glad you came. All right. So thanks a lot, everyone, for joining another edition of the AI Innovation Space. Super excited to such a great conversation with Ali, and we're looking forward to talking to you soon.
This has been the AI Innovation Space, sponsored by Illumin. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Illumin website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.